All right, we spent a lot of time talking about the weather down here on Earth, but let's focus on space. New research suggests that geomagnetic storms can cause immediate changes in precipitation, surface temperatures, and other weather conditions. It turns out the powerful solar storms could alter weather patterns almost immediately, which I find that fascinating. Joining us right now is the lead author, Joachim Raeder. He's also the University of New Hampshire physics professor. Jimmy, thank you so much for joining me right now. This is fascinating to me because we always know the solar flares come, they go. You talk about the aurora borealis get stoked up, but what about the immediate effects on the weather?
Well, that's what my research concerns. I mean, I was very surprised by that myself. I've been intrigued for a long time. I mean, how the solar cycle actually shows up. I mean, in weather data and climate data. I mean, that's been known for more than 100 years. So now we have data available that allow us to do a much more detailed analysis, and that's what I did. And so I found out that geomagnetic storms actually do affect the weather and very profoundly.
That's amazing. So it's an 11-year cycle for the sun when it flips its poles. Where are we right now in the sun cycle?
Yeah, the solar cycle, I mean, peaked probably about a year ago. You cannot tell exactly when it peaks until after a few years later, because sometimes you get a little double peak or a plateau or something like that. So we are really in the downward cycle now. So, but that is significant because the biggest storms actually don't happen at the peak. They actually happen during the downward cycle. So there's still a lot to come.
Wow. So we got maybe a couple of years left of the enhanced solar spot?
Probably more like 4 or 5 years. I mean,
okay.
until we really reach the minimum. Yeah.
Wow. So you got a lot of data, right? I think your data went back for space weather 67 years, and you looked at that and you coupled it with the climatic patterns. What exactly did you find with the short-term effects on the weather?
Well, what I find is that, you get an effect. I mean, and so I created kind of maps, like weather maps, for temperature, pressure, precipitation, and so on. And you get an immediate effect. And the important part is that the stronger the storms are, the greater the effect is. Okay, so if you actually, weak storms have a little effect, they do a little bit, but the strong storms can have statistically effects. I mean, for example, up to 20 degrees centigrade. I mean, different temperatures, compared to the average, compared to long-term averages.
Gotcha.
Yeah.
Why do you think that happens? Why do you think it's affecting the Earth so far down? You're talking about almost near the surface of the Earth, and it affects it almost simultaneously.
Right. Okay. So this has been a debate, I mean, scientifically for decades now. I mean, there's several hypotheses. One basically says it's the modulation of cosmic rays by the sun that come down on the Earth, which in turn change the cloudiness. So as you get more clouds, I mean, more sunlight gets reflected and things would cool down, and vice versa. There's another hypothesis that says it goes through the polar vortex. So over the solar cycle and also during a solar storm, the output, the light output, the visible light output doesn't change very much, but the output in UV radiation, X-ray radiation, and so on, that changes very dramatically, and that affects not directly the troposphere where we live, but the stratosphere above us. And so there's now the idea that it first affects the stratospheric polar vortex and then propagates down to the tropospheric polar vortex. That's the thing that gives us this really cold weather sometimes in the winter. It is also a phenomenon that is primarily active in the winter, and that rhymes with my results, which show that, I mean, these effects are much stronger in the winter than they are during the other seasons.
No, it's absolutely fascinating to me, and I'm still trying to wrap my head around it if this is true. I mean, what do you think is a long term? Can we put this in the computer models? If we get a lot of maybe a coronal mass ejection that's huge, can we automatically put in a weather model?
I think eventually, yes, but it will take quite a bit of a time because the models do not include that physics just yet.
Right.
I mean, the models cannot really reproduce it. But I hope that my colleagues who do the modeling start actually working on that. I'm pretty sure they will eventually. The other thing is the solar storms or geomagnetic storms are still not easy to predict. I mean, we can see stuff happening on the sun, but that doesn't necessarily mean it actually reaches the Earth, and that you see that on the web. I mean, there are often predictions of, tonight, there will be aurora borealis, and then nothing, So that is also still very much in development, and of course space weather of all kinds of sorts affects us. So there's quite a bit of research being done, I mean, to get a handle on that.
Jimmy, it's fascinating stuff. And I was reading up on it before the show. I'm thinking, how am I going to get into a Friday? It's it's supposed to be a nice and easy day. Here I'm reading up about the atmospheric physics and space weather, and I'm trying to talk to a professor. You nailed it, though. You brought it down to layman's terms perfectly, Jimmy. I appreciate you.
Thank you very much.
Yeah, good luck with the
pleasure.
research. I hope that it comes out where we can actually put it in computer models. But as you said, even if we get a coronal mass ejection, is it pointed directly at the Earth? It's still very up in the air how we can do it.
Yeah. There are. I mean, we don't have enough observations. We would need more satellites actually observing the sun. We need more computing power.
Yeah.
I mean, that's true for weather forecasting as well.
100%.
And you need the money. I mean, to actually pay the people who actually do the work.
That's another thing too. There's many aspects going on.
Develop the models. Although I can say, I mean, if we have the time, I mean, the big development recently is artificial intelligence, which is enormously helpful actually in developing models, for example, because it can do a lot of coding tasks that would have taken us weeks or months to do, I mean, in an hour, or less,
Yeah.
So things are actually moving forward. That's the good news. Yeah.
Future looks bright. I mean, it's fantastic, and it is fascinating. Professor, thank you so much for taking the time out and talking to me. I appreciate it.
You're welcome. It's my pleasure too.
Yeah, happy
Thank you.
Friday.